between two means, two proportion, and two variance. Test the difference between sample means using the z-test. Test the difference between two means for independent samples using t-test. Test the difference between two means for dependent samples. Test the difference between two proportions. Test the difference between two variance or standard deviation. Testing the difference between two means using the z-test. The z-test for two samples mean test is another parametric test used to compare the means of two independent groups of samples drawn from a normal population if there are more than 30 samples for every group. Suppose a researcher wishes to determine whether there is a difference in the average age of nursing students who enroll in a nursing program at a community college and those who enroll in a nursing program at a university. In this case, the researcher is interested in the average age of all beginning nursing students. Instead, he is interested in the comparison the means of the two groups. His research question is, does the mean age of nursing students who enroll at a community college differ from the mean age of nursing students who enroll at a university? Here, the hypotheses are mean sub 1 equals mean age of all beginning nursing students at the community college. Mean sub 2 equals to mean age of all beginning nursing students at the university. Assumptions for the test to determine the difference between two means. The samples must be independent of each other. That is, there can be no relationship between the subjects in each sample. The standard deviation of both populations must be known, and if the sample sizes are less than 30, the population must be normally or approximately normal distributed. The theory behind testing the difference between two means is based on selecting pairs of samples and comparing the means of the pairs. The population means need to be known. All the possible pairs of samples are taken from populations. The means for each pair of samples are computed and then subtracted, and the difference are plotted. If both populations have the same mean, then most of the difference will be 0 or close to 0. The variance of the difference mean sub 1 minus mean sub 2 is equal to the sum of the individual variances of mean sub 1 and mean sub 2. That is, so the standard deviation of mean sub 1 minus mean sub 2 is square root of sigma sub 1 squared over n sub 1 plus sigma sub 2 squared over n sub 2. So the formula for the z-test for comparing two means from independent populations is z equals to bar x sub 1 minus bar x sub 2 minus mu sub 1 minus mu sub 2 over square root of sigma sub 1 squared over n sub 1 plus sigma sub 2 squared over n sub 2. This formula is based on the general format of test value equals observed value minus expected values over standard error. So the formula in standard error of the difference is square root of sigma sub 1 squared over n sub 1 plus sigma sub 2 squared over n sub 2. In the comparison of two sample means, the difference may be due to the chance, in which case the null hypothesis will not be rejected and the researcher can assume that the means of the population are basically the same. The difference in this case is not significant. On the other hand, if the difference is significant, the null hypothesis is rejected and the researcher can conclude that the population means are different. Hypothesis testing situation in the comparison of means. So in this situation, difference is not significant. Therefore, do not reject the null hypothesis since difference is not significant. 2. In situation B, difference is significant. Therefore, reject the null hypothesis since difference is significant. The basic format for hypothesis testing using the traditional method is: Step 1. State the hypothesis and identify the claim. Step 2. Find the critical values. Step 3. Compute the test value. Step 4. Make the decision. And Step 5. Summarize the result. Example: hotel room cost. A survey found that the average hotel room rate in New Orleans is $88.42 and the average room rate in Phoenix is $80.61. Assume that the data were obtained from 2 samples of 50 hotels each and that the standard deviation of the population are $5.62 and $4.83 respectively at 0.05 alpha. Can it be concluded that there is a significant difference in the rate? State the hypothesis and identify the claim. Hypothesis must be equal and not equal. Find the critical values. Step 2. Since alpha is equal to 0.05, the critical values are positive 1.96 and negative 1.96. Step 3. Compute the test value. Using the formula, you may convert the following given examples. Step 4. Make the decision. Since 7.45 is greater than 1.96, you must neglect or reject the null hypothesis at 0.05 alpha. Step 5. Summarize the result. There is enough evidence to support the claim that the means are not equal. Hence, there is a significant difference in the rate.